Hello pupils of the 21st century. I am Daniel Bernoulli himself. I was brought back from the dead to teach you about my equation. What? You don't buy it, do you? Come on, it's Halloween, just roll with it. Simply put, the equation describes the relationship between pressure, velocity, and elevation of a fluid. Here is an apparatus that I've built to demonstrate these relations. As shown, I've punched 3 holes at different heights in the bottle. Let's observe the flow of water at each height. As we can see, the hole closest to the bottom has a fluid velocity that is much greater than the hole closest to the top. The difference in velocities can be best observed when all holes are opened at once. So, why is this happening? What does the height of the hole have to do with the velocity? My equation has the answer. The equation gives us a relationship between the pressure, velocity, and height at any 2 points in a steady streamline flowing liquid, in our case water. This brings us to some key assumptions that we have to make. First, the flow is a steady flow. Second, the liquid is incompressible. Third, the viscosity of the liquid is small. The water used in my apparatus satisfies these conditions. Consequently, we can use the equation to solve for V2 as a function of height. Firstly, we notice that both the top and the bottom of the bottle are exposed to the atmosphere, so in both cases the pressure is the same. This means that we can cancel it from both sides. Secondly, we assume that the velocity at the top of the bottle is negligibly small, so the V1 term cancels out. We begin to isolate V2 by moving H2 to the other side and factoring out density and gravitational acceleration to get the following form of the equation. Since the density of water is the same throughout, we can cancel it from both sides. Now we find that V equals square root 2g delta H. When we plug in the height of each hole, we find that the closer the hole is to the bottom, the higher its flow velocity. This explains why the water from hole 1 at the bottom seemed to gush out so fast compared to the other 2 holes, and why the water at hole 3 at the top seemed so slow. My pupils. Unfortunately, our journey together has reached its conclusion, and it deeply saddens me to say farewell, but I have some trick-or-treating to do. See you later.